Hey, Mr. Chewei. As you know, my name is Jonathan, and now in my video below, I'm going to talk about some facts about the periodic table. The first topic is why the elements of the periodic table are arranged as the way it looks now. One of the persons who tried to organize the periodic table is this guy below, which his name is Mendeleev. Well, that is not his name, it's his last name. His full name is Dmitry Ivanovich Mendeleev. He tried to classify the elements for the value of their atomic mass in rows and columns, with the purpose that all these elements get presented in a column with similar behavior. And now the groups. Here we try to locate the element in the group or family of elements with similar properties. Electronic structure of the last layer similar, metal, non-metal, or metalloid, etc. In the classification, the properties of the element are indicated. We have groups from 1 to 18. Group 1 are the alkaline metals, group 2 alkaline earth metals, group 3 to 12 transition metals, group 13 ground metals, group 14 carbonate metals, 15 nitrogenous elements, 16 chalcogenous elements, 17 halogens, and 18 noble gases. Now, metals, nonmetals, and metalloids. Metals are generally shiny, malleable elements that conduct heat and electricity very well. Most of them are solid at room temperature, and it reacts with positive ions that we call cations. Metalloids have properties that are in between those of metals and nonmetals. And nonmetallic elements have more variety properties than metals. They are poor conductors of electricity and heat, and their reactions from negative ions we call anions. Okay, now we have alkaline metals, alkaline earth metals, halogens, and noble gases. The alkaline metals are found in group 1 of the periodic table. So this means that the alkaline metals have one electron in their outer shell. And they are malleable, ductible, and good conductors of heat and electricity. The alkaline earth metals are found in the second group of the periodic table. These elements have an oxidation number of 2 that makes them very reactive. Then the halogens. The halogens are 5 non-metallic elements found in group 17 of the periodic table. The halogens have 7 electrons in their outer shell, with an oxidation number of -1. And these elements can be in gas, liquid, and solid and room temperature. So they are very weird. The noble gases are found in the group 18 of the periodic table. These elements have an oxidation number of 0, and these noble gases have 8 electrons in the outer shell, making them stable and highly non-reactive. The electronegativity of an element is the tendency of an atom to attract electrons when it's chemically combined with another atom. When higher it's gonna be this, higher is gonna be the capacity to attract. The electronegativity of an atom in a molecule is related with the potential of ionization and his electroaffinity. An atom with an electroaffinity electronic very negative is a potential ionization. It will attract electrons of. And finally, our last topic, the atomic radius. This refers to the mean distance from the center of the nucleus to the boundary of the surrounding electron cloud. We can determine the radius by dividing the distance between two bonded atoms in half. Depending upon the type of bond, we can obtain very different values. And here in the table, we can see the behavior of the atomic radius in the periodic table. And well, that's everything for my project. I hope you like, Mr. Chewei, and see